Hi everyone, my name's Kyle Thompson. I'm a senior engineer on the AWS IDE Toolkits team. At AWS, when we say toolkits, what we mean is extensions to IDEs or plugins, depending on the IDE that you're familiar with. And today what I'm going to take you through is how you can use our toolkits, our IDE extension offerings, to help you building a serverless application. So what we're going to be looking at is a non-trivial application. This isn't just a simple hello world application. There's several layers to it. And what I'm going to show you is how you can use the toolkits to make your life simpler when you're developing, when you're debugging, when you're trying to understand what's going on inside your application. So let's have a quick look at the agenda. We're going to start off by reviewing some tools that I have installed on my local developer desktop. These are tools that you're going to need to use some of the toolkit features. Then we're going to jump into a demo of getting the IDE extension set up, authenticated with AWS, and deploy our sample application that we're going to be playing around with today. After that, we're going to come back to the slides and we're going to start looking at the actual architecture of the application. Like I mentioned, it's a non-trivial application. It's not just a simple hello world application. And so it makes sense for us to actually have a look at some of the services that we're going to be integrating with as part of the application itself. But once we've done that, we're going to go back into the toolkit and we're going to demo some workflows for troubleshooting problems and how you can use the features of the IDE toolkit to help you with that. So let's jump in and have a look at some of the tools that we'll be using. So of course, we're going to have the AWS toolkits. So like I mentioned, when we say toolkit at AWS, what we mean is an IDE extension. In this case, in the demos, I already have the extension installed into my JetBrains IDE. I'm using IntelliJ in this case. So I already have it installed. I've installed it from the marketplace, but I'm going to take you through getting authenticated and getting set up. I'm using JetBrains today, and I'm using the IntelliJ Enterprise Edition or Ultimate Edition. And the reason I'm using Ultimate Edition is because some of the features that we're going to be looking at today require Ultimate features from IntelliJ. So we are using the database integration features that IntelliJ provides as part of its DataGrip IDE, or with the Data Tools plugin in IntelliJ Ultimate. I also have the application itself is also a polyglot application, and we have TypeScript. And WebStorm is one of the premium IDEs that JetBrains vends, and I've installed the Node extension into Ultimate Edition, and that's only available in Ultimate Edition. The toolkit itself does work in all editions of JetBrains IDEs, including the community editions, but if you have dependencies on some of those ultimate features, then they just won't be available in those IDEs. It's also worth mentioning that we vend IDE integrations for other IDEs as well. So AWS Cloud9, Visual Studio, and Visual Studio Code. But like I mentioned, today we're going to be focused on the JetBrains suite. Next up is the AWS SAM CLI. So the SAM CLI, for those who haven't seen it, is a tool, a local tool vended by the Lambda team that allows you to run and debug Lambdas and API gateway functions locally on your machine using a Lambda-like container and Docker. We're able to actually simulate the Lambda environment. The toolkit integrates with these features, and I'm going to show you how you can use the local debugging capabilities to actually get step-through debugging in your IDE in a Lambda-like environment using the SAM CLI. And then finally, because this is a complex application, we want to actually model our infrastructure. It's not sufficient to go and set that stuff up manually in the console. And so I'm using the AWS CDK, which again, for those who haven't heard of it, is the Cloud Development Kit. And it is a way that you can model your infrastructure using regular code. And that then is able to emit a CloudFormation template and use CloudFormation itself as the deployment engine. And we're going to see that in action in just a few minutes. CDK assists you in bundling all of the assets of your application and actually deploying them along with the services themselves and provisioning those services. So with those tools set up on my local machine, let's dive into a demo. So what we have here is an open source project. It's hosted on GitHub. I have the JetBrains Toolbox extension installed into my browser, so I get these buttons to clone in the IDE. So I've clicked that, and it actually opens up IntelliJ for me and helps me through the checkout process. So this isn't an AWS Toolkit feature. This is a JetBrains feature that allows us to get started more easily. So while that's indexing here, what we're going to do is we're going to dive into the actual Explorer itself. So like I mentioned, we already have the toolkits installed. And so on the left-hand side here, I have this AWS Explorer pane. Now, my company uses SSO to authenticate, which means I have two profiles here, an SSO one and a developer account that depends on that. I'm going to select the developer account, and the toolkit is going to detect that it's an SSO profile and prompt me to open a browser to take me through that SSO login flow. So here I've already got my username pre-populated. I'm just going to put in my password. I'm going to hit sign in. And then I'm going to hit sign into the application and go back to the IDE. And now you can see we have some resources in the Explorer, although it's empty because this is a fresh account. Now, because I have that node installation in JetBrains, it's detected that I have npm packages here and it's prompted me to install, so we're going to let that go. And then we're going to run our deployment. Now, in order to do that, I'm going to use a local shell that uses the same credentials as the toolkit is currently using this AWS Local Terminal button at the top of the Explorer. This is a new feature, and you can see here we have the context of my current connection. So if I run sts get caller identity, you can see that's the user that I've connected with that dev account there. Now, in the top level of the project that we just checked out is a deploy script, deploy to sh. So I'm just going to run that. And this is going to facilitate the CDK installation process that we talked about before. So what CDK is going to do here is first it's going to bootstrap my account, which is effectively creating a bucket for it to put the code assets that we're going to create as part of the deployment here. That happens once per account. Then what it's going to do is it's going to actually bundle all of the source in my application. So that includes kind of running npm, resolving dependencies, bundling the Lambda functions that I have here. I also have some an ECS service, and so I have the image that is associated with that. We're going to see all of this detail when we go through the architecture in a minute. Then it prompts me, tells me everything it's going to do, gives me the option to confirm. I'm going to hit yes here. And now it's pushing up those artifacts to that assets bucket that we talked about before. And once it's done that, it's going to kick off a CloudFormation stack deployment to provision all of the infrastructure for the application that we're going to be looking at today. So once this pushes, it's going to start a CloudFormation change set, and we're going to use the AWS IDE Toolkit CloudFormation functionality to actually monitor that. So now that that deployment has started and we can see we've had a stack created, I'm going to go up into the Explorer, refresh, expand out the CloudFormation node, and double-click on that stack. And from this view, I can see a real-time view of my stack that updates periodically with new resources. I'm going to uncheck the tick mark here so that I don't show completed items. I'm mainly interested in those that are in progress so we can see what we're waiting on. We get events, we get a list of resources, and ultimately we'll get some outputs when the stack completes. Now this takes a few minutes to run because I have an RDS database instance, I have a load balancer. These are resources that do take a few minutes to actually spin up. So what we're going to do is we're going to let this run. We're going to let this run in the background, and while we do that, we're going to jump back and have a look at the application that we're actually going to be demoing today. So it's a beer-related application. You might be able to tell from my accent I'm Australian, we like beer. And what I really want to do is I want to figure out if an image that I've uploaded contains beer or not. And if it does contain a beer, then ideally I want it to tell me what type of beer. And we're going to use AWS recognition for this, the image recognition service, to do detecting labels. So let's take a look at, this is the kind of entry point that customers are going to use, but let's have a look at what's going on in the back end. So we have obviously users hitting the system. they come in through an application load balancer. We want this to be highly available, and so we're using an application load balancer. That's going to route requests to an ECS web service that has 5 tasks running on it. Like I mentioned, we want it highly available, and so we have several tasks running that's going to be able to handle that traffic. This is a Kotlin Spring Boot based image that we've created for vending these or for serving these requests. So this is the kind of image upload flow here. So the image is going to go into an S3 bucket for initial storage, and that is going to trigger a Lambda function to process that image. So we have triggers set up as part of our CDK infrastructure definition between that upload bucket and the Lambda image processing function. The image processing function is going to call out to Amazon Rekognition to do detect labels and figure out what's in the image. Then once we get that information back, we're going to publish into an SNS topic, the metadata that we've gathered about that image. And the topic has 2 destinations. So the first is a TypeScript node-based Lambda function that we're going to use to store the metadata in an RDS database. So we have a traditional relational database here through RDS that's going to store the metadata for us. The other destination is going to be an image resize function. So this is a Python function that is going to resize the raw image into a thumbnail size and store it into a storage bucket. It's also going to delete the uploaded image from the image bucket so that we know it's been processed. So this is kind of our upload flow, our write flow. But for the read flow, we also have customers coming in through the front door into that application load balancer and hitting our ECS web server. Then that web server is going to query our RDS database for metadata, return a page to the customer with the URLs for the images that we saw on the left-hand side, and those URLs are going to be vended out through a CloudFront CDN. The CDN is backed by this storage bucket, so anything we put in that storage bucket is going to be available in CDN locations for that, for getting that faster latency for customers. Now, all of these compute types here, all of these orange squares and boxes, the Lambda function and the ECS web server, of course, publish logs to CloudWatch Logs. And this is kind of the full overview of our application. As you can see, there are several different services involved, multiple layers, multiple hops. And when we're talking about trying to rationalize this as a developer, this is where the toolkit comes in and can help us out. So once again, a quick run through of some of the tools that we're using. Like I mentioned, we're using the IDE Toolkit. We already have that installed and set up. We're using IntelliJ IDEA in this case. We use AWS CDK, so Cloud Development Kit, to model our infrastructure, and we have the CDK CLI installed locally, which was what was kicked off by that deploy script. We have the AWS SAM CLI, which we're going to use to debug Lambdas locally. And then we are storing our source on GitHub. So let's dive back into the IDE and see where things stand. So you can see here the deployment has completed. I get a notification. I have the resources down the left-hand side. And most importantly, I have the Outputs tab here. So this gives me a URL to the application load balance, which I'm going to copy and paste into a browser and try and load it up, and we get an error. So let's try and figure out what's going on here with this problem that we faced. So we're going to open up the README, which contains a copy of that architecture diagram so we can see the pieces. And we can see the first thing that happens is it comes in through our ECS web service. So we're going to go into our Explorer. We're going to refresh the screen there, and we're going to right-click on the cluster and hit View Logs. And that's going to open up the log group for the ECS web service there. Now, I mentioned that there's 5 tasks running, and rather than looking through each of these individual log streams looking for the exception, what we're going to do is we're going to use the search functionality. So I'm going to hit this little search icon here, which is going to pop up a CloudWatch Logs Insights query. You can see I could write a complex query down the bottom using the query syntax, but I'm just going to look for a simple string here. This is a JVM application, and so exception is probably somewhere in the stack trace. So I'm going to put exception in the text box there, and I'm going to hit execute, and that's going to then query across those log groups. And if we look at the second entry here, we see an exception that says the main.things table doesn't exist. So we know there's an RDS database that the web service hits when it loads up, but it looks like there's something wrong with it. So once again, we're going to expand out the RDS node. I'm going to right-click on our database and hit connect with Secrets Manager, and the IDE is going to prompt me to select the secret that I want to use to connect to that database. So I only have one in this case, so I'm going to hit select that one and hit select, and this is going to pop me into the JetBrains data sources connection pane. Now, I could just connect to this directly, but I want to connect to the specific database instance that we have, and we know it's called main because we're looking for a table called main.things. So I'm going to type that in there, hit test connection. That connection's created now. I hit OK. And if I expand out the databases tab on the right-hand side here, I see I have that connection now. And this is securely connected using Secrets Manager. But the main database has no tables in it, so that's probably why we're getting the problem. So I'm going to right-click on that, select Run SQL Statement, and as part of the project, we have the schema itself. We're just going to open that up, which will run that DDL statement and create our table for us. So we can see now we've got a things table in there. So we're going to go back to the browser and we're going to refresh. Okay, so the web page is loading now, but we don't have any images because we've just deployed this application. So what I'm going to do is I'm going to actually upload a sample image that I have. So I have some images of beer here. One of them is a stout, so we're going to drag that across, and that's going to upload to that image upload bucket, trigger the Lambda, and trigger that whole processing flow that we talked about just before. Okay, so when we refresh, we get a result now. We've detected that it's beer, we know that it's stout, but the image isn't loading for some reason. So let's try and figure out what's going on there. So the images are served up through this CDN and stored in this storage bucket. So we're going to go over to the AWS Explorer on the left-hand side and expand out the S3 node and load up double-click the storage bucket, which the IDE is then going to open up the bucket browser that the toolkit provides and let me look at the objects that are in there. So I have a thumbnail directory. That seems to make sense. But the image that's been uploaded seems to have duplicate extensions, so that could be an indicator for what's going on. We're going to go back across to the web page and just have a look at the actual image URL itself to see if there is a duplicate one. There isn't, so we're only looking for .png. So somewhere along the line we're getting an additional extension added here. So let's try and figure out what's happening. This table is populated, if we go back to our architecture diagram, this bucket, is populated by that resize function, which is triggered by the SNS topic there. So what I want to do is I want to see what's going into that topic. So to hook into that, I'm going to subscribe an SQS queue to it. I'm going to create a new SQS queue for this because I don't want to interrupt the flow of my application. So again, I've gone to the SQS node, I've gone create queue, put in a queue name, and now I'm going to go and hit refresh, and we'll see that queue has been created through the toolkit. I'm going to right-click on the node in the Explorer, and I'm going to go subscribe to SNS topic. This is going to pop me up with a window to select the topic I want to subscribe to. Again, I only have one in this account, so it's just a single entry there, and hit subscribe. Now, the toolkit detects that I don't have the correct permissions in order for this subscription to work. So it's going to prompt me to create a new policy, and it gives me a preview of the policy that it's going to create on my behalf and asks me to confirm. So I'm okay with that. I'm going to hit add policy there. And now we see that now that SQS queue rather is subscribed to the topic. So we want to trigger another message here. Now, rather than uploading to the website directly, I've opened the image upload bucket inside the toolkit. I'm just going to drag and drop from Finder into that bucket. You can see it's uploading at the bottom of the toolkit there. We're going to give it a second for this to process through. Like I mentioned, the resize Lambda function deletes it from this bucket when processing is complete. So we should be able to refresh this, and if it's disappeared, then we see we have a new entry here, but the same problem with the image not being not loading. So we're going to go into our SQS queue. We're going to double click on it. We're going to right click on it, go view messages, And we're going to hit poll messages here. And we can see we get that message from our SNS topic that we had subscribed to. So this is the notification message that's actually coming into our resize function Lambda. And we can see that the extension is correct here. So I'm going to copy that message. I'm going to go and find my resize function. I find it inside the Explorer. This is the remote version. I'm going to right click on it and go jump to source. So the IDE applies a heuristic to find the source locally. So this takes us to the actual handler that we've got checked out as part of this project. So what I'm going to do here is I'm going to click the Lambda gutter icon, and I'm going to go debug, because I want to debug this locally, see what's going on here. I can pick a template event. We know this is an SNS notification, so I can pick one of the SNS options and just replace the notification section with the notification message that we captured from the SQS queue. So I'm going to replace that there. Then I'm going to hit apply and debug, and this is where SAM CLI comes in. The SAM CLI is going to attempt to build the function. But there's a problem. We don't have the right version of Python on my local machine. But that's okay. So I'm going to go back into the run configuration, and from the SAM CLI tab, I'm going to elect to build the function itself inside a container. So this time, when I hit debug, the SAM CLI is actually going to resolve a Docker container that contains the correct version of Python on my behalf, build that function, spin it up, and attach the IDE's debugger to it. So at this point, the IDE debugger is attached, and I have a full step-through debugging session with my Lambda running in a Lambda-like environment locally. And we see we're adding a PNG spuriously. We don't need that additional PNG there. It's already in the thumbnail name. So pretty simple thing to fix. We should be able to just delete this additional piece of code. And what I'm going to do now, rather than doing a full asset deployment, stack deployment, I'm just going to upload directly from the toolkit. So I'm going to do that from the Lambda that I want to update. Again, it's located the handler locally. I do need to pick a bucket for it to go in. I'm going to use the CDK bucket that we're using for the asset system, building container, and deploy. And this again is going to use the SAM CLI to bundle up this function and push it into that S3 bucket and then facilitate a Lambda deployment for me. So I don't need to do a full stack deployment. This is just deploying this single Lambda function, so we have a faster kind of iteration time. So now that we've done that, and I'm pretty confident we've resolved the problem, what we're going to do is we're going to upload a few more files just to double check that we've resolved the issue. So I'm going to go back to my upload bucket and find my sample images. This time I'm going to upload something that isn't beer, and we're going to pick another beer. So we're going to upload an image of a lager. So those things are going to upload. They should get deleted from here once they've been processed. So we're going to just refresh this until they've been deleted. And then we're going to go back to the web page, hit refresh, and there we have it. We have a fully working end-to-end application that can detect beer. I'm just going to go and correct the old images that were incorrect by going into the browser again, the S3 browser again, and renaming them through the browser, the S3 browser window there. So once I rename those, I can go back to my application, refresh, and there we have a fully working end-to-end application that can detect beer in images and serve them up on a web page. So I'm done with this stack now. So what I'm going to do is I'm going to right-click on it and go delete stack. And the toolkit's going to prompt me to put in the stack identifier just to confirm that I do want to actually delete this. And I'm going to hit OK. So now this is going to pop open the stack window again and run us through that deletion process. And what we've ended up there with is that the application will get deleted. So let's take a look back at what we just saw in those two demos. What kind of functionality does the toolkit give us to be able to debug non-trivial applications? So first up, we used the SSO mode to authenticate the toolkit with AWS, so I don't have any credentials stored locally on my machine. I'm using fully federated access through SSO, and the toolkit facilitates that login process. The next thing we saw was the AWS Local Terminal. So this was that little command icon that we clicked at the top of the Explorer. This is a feature that as of January 2021 is in a development branch, and it's something that we're looking to release in 2021. So it's a feature that lets you have context-aware local terminals to run other AWS CLIs. Then once the CloudFormation Stack deployment had kicked off, we looked at the Stack Viewer to kind of monitor the process of that deployment. Once it had deployed and we'd hit the application and saw that there was an error, we went and looked at the CloudWatch logs inside the toolkit. And since there were multiple log streams, we wanted to query across them. We used the Insights query functionality that the toolkit provides. We then looked at the RDS database integration and used that to actually connect securely to our RDS database and add it as a data source in the IDE. Again, without using passwords or manual credentials, using Secure Secrets Manager for that connection. Then we use the S3 browser, and we use this a few times to upload and rename some objects and kind of monitor things as they were going on. We use the SQSQ integration of the toolkit to bridge to an SNS topic so we could see what messages were flowing through our application. Then once we'd kind of nailed it down to the Lambda that we thought was the problem, we used the SAM CLI and the toolkit functionality that goes along with it to locally debug that function and do a full fidelity step-through debugging process in a Lambda-like environment. We then fixed the problem and deployed directly from the toolkit just that one Lambda so we could see the process and whether that had fixed the problem. So these are just some of the features that you can use in the toolkit to help you troubleshoot and work with non-trivial serverless applications. We looked at IntelliJ for the most part, but what about other IDEs? Like I mentioned, we vend toolkits for other IDEs, and in this fictional scenario, I have a colleague who develops in a web browser and he uses AWS Cloud9. So what we're going to do is we're going to get him to take a look at the code change that we actually made there. So in Cloud9, I have the toolkit installed here. And again, I have the AWS pane on the left-hand side, this kind of familiar AWS browser. I'm going to expand out the Lambda node, right-click on that resize function, and I'm going to import. So in this case, we haven't even downloaded the code. We're just going to directly import that Lambda function from the console. And we can see here we've got my source code. And what I'm going to do is I'm going to actually, again, run a local debug session to verify that the problem was resolved. As a payload, I'm going to cheat a little bit and copy and paste the payload that we used from the JetBrains toolkit, but this is the payload that we're going to invoke the Lambda with locally. And in this case, we're going to create a new S3 bucket because we don't want it to affect the running, the triggers of the application. So I right-clicked on that node. I'm going to type in a bucket name here, so I need to put some numbers in to make sure it's unique. And then I'm going to pass that bucket name, once it's been created, I'm going to pass that bucket name into my function with some environment variables. So if we go back to the function here, we can see we're looking for both the source and upload bucket. I'm just going to use the same bucket for both, pass those as environment variables. Now we're going to upload a test image. Now in our test message there, we're looking for Porter, I believe it is. So we're going to upload that. And once that's completed, we're going to actually kick off a debug session locally. So set a breakpoint, hit run, and once again this uses the SAM CLI to spin this up and attach the debugger to it. In this case we're using Cloud9's debugger, and we have again a full fidelity debug session. We can inspect variables, we can step through. So we're going to hit play there, let that play out. That's going to process the rest of the image. We should see it get renamed here, and we do. We have that thumbnail directory, and it's been successful. So my colleague in Cloud9 has kind of verified that the fix has worked. So now we also have importing, in addition to some of this functionality in Cloud9, we have importing AWS Lambdas and debugging. Like I mentioned, the source for all of this project is on GitHub. It's open sourced. Please feel free to check it out yourself, run through the demos as we did, and just kind of get a feel for the features that are available to you in the AWS toolkits. With that, I'd like to say thank you. and please complete the session survey.